Hey everyone, it's Matt here with Nightrun Studio and welcome back to our Enemy AI mini-series. So far in the series, we've got our enemy working pretty well. He can attack and deal damage, the player can do the same. We've even added the ability to slide in order to evade attacks. That said, death itself is rather lackluster as just plain nothing happens. So in this video, we're going to add a death state to both the enemy and player. We'll show two different ways to handle death. The first, where the enemy explodes in a sort of burst of death parts, and we'll also show how to do an animated death sequence like this one for our player. Additionally, we'll add a slow motion effect so that as he dies, we can slow things down and then resume back to normal speed afterwards. That's where we're headed in this video. Let's get started. Alright, so let's begin with our enemy death as that's the simplest. And if you've been following along the entire series and you did the target dummy episode, you'll actually have all the stuff you already need. That said, let's show how this is going to work. So in our target dummy episode, we actually split our dummy into a bunch of little parts here that go exploding as soon as it gets destroyed. We're going to do the same thing with our kobold. You'll notice that each of these has just a sprite, a rigid body, and then a collider so that they can shoot up into the air and bounce around in a kind of a fun way. So let's head into our kobold assets, go to the no outline, and we're going to just use the idle sprite here. I'm going to duplicate it first of all, and then we'll just call this one death parts. We can then open up the sprite editor. So I'm just going to start off by taking the slices we already have and just resizing them. I'll do one for his head, and I'll just name this one Kobold Head. Now you'll notice that this isn't exactly perfect. For example, his scarf shows up in the head one, and none of them are going to slice exactly perfectly. If you'd like to take the time to do so, you can always head into a visual editor like Photoshop or Sprite and clean these up yourself. And then when we're all done, we can just apply those changes and close the sprite editor. Alright, with that done, we can just open up the death parts here, and let's grab the first one, the arm, and just drag it up into our hierarchy. From here, we can add a capsule collider, and I'll just resize it if needed to make sure that it fits well, and then also add a rigid body. While we're here, I am going to just make sure that the rigid body has a little extra gravity so these don't seem too floaty when they go spraying. From here, I'm just going to make 5 copies of this so that we can quickly reproduce them, and we'll give each one a new name. So the next one up is going to be our Kobold Head. We can head to our sprite editor and just drag the head into that box. Next, I'll head into the capsule collider where I'll change the direction to horizontal so we can have a lying down capsule, and I'll edit the collider so that it fits the shape of his head. At that point, we're ready to move on to the next part, which for me is his leg, and we're just going to repeat this process for each of the parts, adding a capsule collider, reshaping it, and then a rigid body as well. Alright, with all those parts created, let's head into our prefab folder and create a new folder. This one can be for our Kobold death parts. We can then just shift click each of those parts that we just created and drag them in here. Now we'll have access to them in our assets folder so we can instantiate them whenever the enemy dies, and we can delete all the copies that are here in the scene. Now again, if you've been following along all this time, you'll already have a death parts set up for your enemy in his enemy damage, and we can literally just lock the inspector and drag all of these in here. That said, in case you've not been following along or you just forget how this works, let's take a look inside of enemy damage. First of all, at the top, you'll see that we have an array here for death parts. That's where we drag them into. And we've also got some floats which will determine the force and torque and lifetime of these different parts. Now in Handle Death, whenever an enemy dies, we just loop through all the parts in our death parts. We first of all calculate a random rotation for them. We'll then get a hold of the part itself and instantiate it using that rotation. Next, we'll grab the rigid body on whatever part we've just instantiated. We'll calculate a random direction, which on the X will be anywhere between fully left and fully right, but we'll always have a positive number on the Y, so it goes upward. We'll then apply that velocity, the random direction, times the spawn force we set up top to this object so it shoots up in the air, and finally just add some torque. Here we'll just take our torque value and either do a left or rightward torque, and use force mode 2D impulse so that it hits all at once. Finally, we'll destroy that part once its lifetime runs out, and we'll also destroy this game object, which is the enemy. Now then, when I get in the game, I'll just set my enemy's health to 2 so I can destroy him right away, and when I come in and attack, he explodes in a big burst. You'll notice I can still walk into those parts, which looks a little funny, and we can also play with the values a little if we like. So first, let's just shift click each of these parts and make sure that they are all on the enemy layer. We've already set the enemy not to collide with player. That's why we're able to walk through our enemy and not bump into him, and so this will also keep the player from bumping into his parts. Now when I come and destroy the enemy, I can walk through the parts just fine and not have them affect me. Alright, that's looking a whole lot better. Now just for fun, I'm just going to bring the spawn force and torque up to about 3 times their other value, and while you're not going to get the full effect because I'm in a cave here, you can see that when I destroy him now, they go shooting up with a little bit more fun to them. Alright, so this is one way to destroy an enemy. Let's take a look at how to do it with animations while setting up our player death sequence. Now, as always, we'll begin by setting up our animation, so let's drag our animation pane up here, make sure that we're clicked on the player sprite, and then we can go ahead and grab our death animation. This one is found in the generic character pack 1, and if we head to our sprite editor, you can see that we've got quite a few sprites for this one. Here we're going from frame 42 all the way to 53. So let's create a new clip here. I'll make sure that I head to my animations folder, and we can just call this one death. Now I'll just shift click all of the frames from 42 to 53 and drag them up. And since this one won't loop, we don't need to repeat the final frame an extra time. I'm just going to drag these out so they last about equidistant between each of them, so roughly 22 frames. When I hit play, that's looking pretty good. At this point we can head to our animator. Let's make sure we're clicked on our sprite so we have the right animator showing. I'm going to drag death up here by damaged, and let's go ahead and add a parameter. This one will be a bool like all the others, and we'll call it isDead. We'll make a transition that goes into death, and then another that leaves and goes to exit. And in order to enter death, we just need isDead to be true. We can then exit whenever isDead is false, and just make sure that we have no exit time or duration so that it happens immediately if we decide to add resurrection or something like that later on. Now let's move our animation pane back out of here, and we're ready to get scripting. Let's go ahead and create a new mono behavior script, and we'll call this one PlayerDeathState. Now, as usual, we want to get this testable as quickly as possible, so we'll just start by setting up our animation. The good news is all of the hard work we've done in setting up a modular system is going to make this one pretty easy to put together. So first off, let's get rid of our start and update method and make sure that we are inheriting from player state instead of mono behavior. We can then go ahead and create our constructor, which is just going to be a public player death state. Make sure that it takes in a reference to the player and then passes that reference along to the base state. Now we'll create our enter method, and as usual, we'll make sure that we run any logic from the base's enter method. But we also want to tell this animator that it needs to set its bool for isDead to be true. We can then just copy paste that method, make sure that we change it to exit and false, and I forget here, but don't forget to set your base to exit as well. Now, unlike most states, the death state could be called from any state depending on when we take that final hit, and so it won't be called from another state, but instead from our damage. Now, damage is going to get the message from health, which will tell it that we've died, and then it's going to call this handle death method, which is currently empty. For now, all we want to do here is tell our player to change state to the player death state. That almost sets us up to test this out, except that our player doesn't yet know the death state exists, so let's head on over to player. We'll continue to follow our quasi-alphabetical order here and just put death state in. We can then head on down to awake and just make sure that as soon as the game starts, we initialize the player death state and pass along a reference to this player script. I'm just going to hit save all in case I forgot to save one of those along the way, and then before we test, let's just search our death animation up and make sure that we turn its loop time off so that it doesn't play on repeat. I'll then set my player's health to 2 so he can die nice and quickly, and when we get in the game, we do in fact get our animation playing. You'll notice that he went in the wrong direction, and I can still flip, and the enemy's trying to attack me still, so we've got some work to do, but at least for now, things are off to a good start. Alright, so we're going to do the easiest thing first, which is just to stop the ability to flip the player after he's died. For this, we're just going to head into player, and if we head all the way to the bottom of this rapidly growing script, we will find a flip method here. All we need to do to disable it is just check to see if the current state is equal to death state, and if it is, we'll just return early, not executing any of the rest of the logic here. Now when we get in the game, you can see that when we die, doesn't matter how many times I press the buttons back and forth, he is no longer flipping. Alright, next up, let's make it so the enemy doesn't keep attacking us after we're already dead. For this, we'll just head into enemy senses. And here in our chase target, you can see that currently he just looks for anything that is on his target layer, and if he hits something with his raycast, that becomes his new target. Here we're just going to add one more check. So first of all, we're going to make a reference to our player script. We'll call this player. And we're just going to check on the object we just hit on our target layer to see if it has a player script. Now if it does have a player script, we're just going to check to see if the current state of the player is the death state. Now if he is in death state, we're just going to return null so that this gives an empty value for what he's supposed to chase, and he won't notice the player's there and will continue on with his normal states. We can test this one out, and again you can see that now, once the player dies, the enemy just keeps doing his thing. Now next up, let's get some knockback so the player goes in the right direction when he dies and also actually gets pushed. This is going to originate actually inside of our health script. Now already our damaged event is passing along a vector 2, so we know where the attack came from. We're just going to do the same thing to our on death. Then when we invoke it, we'll pass along the source position just like we do with our on damaged event. Now here we can just follow the errors for what we need to fix. The first one here is taking me to my enemy damage, and we can just see here that our handle death is not expecting a vector 2, so let's change that. We'll call this one source position just like we did up above for handle damage. That was a 2-for-1 special as it got rid of 2 errors, and now we've just got 2 left, so let's go into our player damage and do the exact same thing, making sure that handle death is actually expecting a vector 2 for the source position. Now with that done, our player knows where the attack's coming from, so let's actually copy this logic here from our damage for initiating a knockback. We'll start by setting the direction to 0. We'll then calculate the actual direction by finding out whether the player's x is greater than the attacker's x. Now then, rather than send that information along to the damage state, we'll just tell the death state to set its parameters. That said, death state doesn't yet have a set parameters method, so let's head there next. Now this part's going to look very similar to what we're doing in our damage state, and you could copy paste a lot of it, but I'm just going to go through line by line to make sure we understand what we're doing. We'll start by setting 2 private floats, one for our knockback velocity and the other for our knockback duration. Now we can go ahead and create that public void setParameters method that we were talking to in our damage script, and this one is going to take in an integer for the knockback direction. Now that we know that knockback direction, we can use it to calculate our velocity. So we'll just let our script know that its velocity for knockback is going to be equal to the knockback direction multiplied by our damage's knockback force value, just like we did in our damage script. Now whenever we enter this state, we'll first of all just tell it that its knockback duration is equal to whatever duration we set in our damage script, and we'll also apply our velocity to the player's rigid body. We'll do this by creating a new vector 2, and for the x, we're just going to use knockback velocity, the one we just calculated, and then for y, we'll allow the rigid body to continue to follow gravity and calculate its own velocity. Now that the player is being knocked back, we just need to figure out when the knockback ends, so we'll use our override fixed update method for this, and just make our knockback duration count down. We'll do this using time.fixed delta time. And then if our knockback duration gets to 0 or less, we know we need to stop. So we can tell our player's rigid body that its new linear velocity should be a vector 2, 0, which will just stop him dead. Once again, I'm just going to save all in case we forgot to save one of those scripts along the way. And now when we get in the game and the enemy defeats us, you'll see that we do in fact die. It actually looks pretty good. He goes flying a little bit and then collapses on the ground. That said, if we get hit when we're a little too close to a cliff, we run into a problem. You'll notice here that we are falling in slow motion, and that's definitely not what we want. The problem here is that we're setting our velocity to a vector 2.0 at all times, and we don't want that. So we want our player to actually know whether he's on the ground, and if he's falling, we don't want to apply his vector to 0. And fortunately, our player script already checks all the time if we're grounded and has this isGrounded bool. So we can just tap into that. Here, when our knockback runs out, we're just going to check to see if our player's isGrounded value is true or not. If our player is grounded, then we'll set our velocity to 0. If not, we'll just let him calculate his own velocity so that he continue to fall down cliffs and things like that. Now when we get in the game, we can run a test on this and it will mostly work, however there's still a problem. If I pause while we're in the middle of falling here, you can see that when I touch my cliff, it actually protrudes just a little bit beyond what you actually see visibly, and the player's overlap circle is just barely touching that, so he thinks he's grounded even though he isn't. This is a little annoying and it may or may not bother you depending on the values you've used in your game, but we can fix this by just shrinking our collider a little bit when we die. Fortunately, because of how well we've set up this system, this is actually pretty easy to do. Just as soon as we enter the death state, we'll tell our player that his ground check radius needs to shrink. In this case, I'm just going to use 0.2 as my size. It was 0.35 before. And then we can just copy that, and when we exit the state, make sure that we set it back to its normal value, in my case 0.35. I realize we are using magic numbers here, which isn't always the best way to do things. It might be nice to set up a variable somewhere where we change these. That said, I don't really think that's going to happen, so I think we're okay to just leave it here. Alright, now when we get in game, you can see that when we take damage and fall down a cliff, we do indeed fall down that cliff. At this point, we're very nearly done, except that I promised a cool slow motion death effect. So let's head back into player death state one last time. Here, we're going to start by just making a private bool for is time slow, so we can track when it's been slowed down. Then when we enter this, before we even play our animation, we're going to tell the time that our new time scale is going to be equal to, and pick a slow time here. I'm going to go with 0.3. Remember that 1 is full speed. And now we'll just let our state know that is time slow is true. So when the knockback runs out, if time is currently slow, we'll then set the time back to a time scale of 1 and make sure that it knows that time slow is now false. Now when we get in our game and the player takes that last hit, it does in fact slow down and then go back to normal speed and the enemy does his thing. Alright, thanks to this nice modular system, we've now added death to both the player and enemy relatively easily, even with some cool special effects added. That more or less wraps up our first enemy, so in the next video we're going to head to our second enemy, a sort of hovering ranged enemy, and we'll show how with this system we can now create new enemies quite quickly and easily. Hope to see you in that video. Until then, this is Matt with Nightrun Studio. Cheers.